2.2 part B, we are dividing rational expressions. So just for a review, we're going to divide natural fractions first. So the very first one is this guy that everybody has. We're going to work on that question first. That is on the bottom of page 14. Okay, bottom of page 14. So, what is the one thing we need to do when we divide? Who remembers what we got to do when we divide? Flip n times. Now, which one do we flip? The second one, the one after the divide sign. So the first number comes down normal. The divide changes to a multiply, and the 6 and the 1, they switch places. Okay, and now we're back to multiplying rules. So, we can cross simplify. We look diagonally here. 6 and 3 both divide by 3. He becomes a 1. He becomes a 2. Our final answer would equal 4, or 4 over 1.
So you don't change like 6.
Nope. Nope. That's what the exponents you're thinking of. Because if we had 6 to the positive 3, and he was over 1, and if we flipped him, this would go negative. So you are right. But right now they have positive 1s also. Okay, so we got a positive 4 for that one. You guys don't have these other two examples, so we're going to write those down.
So why don't you get negative 1?
Why don't I get negative?
Like teacher exponent 1.
Ah, okay. The reason is because actually it is a complete reciprocal. You're actually not, well, we call it flipping when we reciprocate things, but when you do a reciprocal of a number, nothing changes with the digits. It just literally changes positions. So it's going to switch from the upstairs to the downstairs. So we don't do anything to those positive exponents. Okay? And it's because we're dividing fractions. Okay? And that's just a straight up rule. Okay? Good question. So the next one is negative 3 over 5 dividing 3 over 20. So now the first one comes down the same way. Negative 3 over 5 doesn't change. Let's get all this out of the way. And then we're going to flip the 3 and the 20. So 20 is upstairs, the 3 is in the bottom. And now we switch it to multiplying. So let's see if we can cross simplify. So 20 and 5, what do they divide by? 5. We get a 1 on the bottom, a 4 on top. We can go cross the other way as well. Between 3 and 3, they both divide by 3. 1 and 1. This guy's going to give us negative 4. Okay? So cross simplifying. Now you don't have to solve them by cross simplifying. What I'm showing you with our cross simplifying here, this process is what we're going to be doing like we were when we were multiplying the expression. Okay, dividing, after we flip it, we still do the multiplying rules. Okay? Yeah? No, it's not wrong if you put it over 1. No, it's just fine. Okay, the next one we're going to look at has a negative 1 over 6. And we're going to change the middle to timesing, and we're going to flip the other two numbers. Now the negative sign will stay on the top though. Okay? The negatives always will float to the top. So it'll be negative 24 over 8. Okay, so negative 24 over 8. So now we're going to take a look at both of the digits. Diagonally, between 1 and 8 we can't simplify, but between 24 and 6 we can. So 24 and 6 both divide by 6, becomes a 1, becomes 4. Now, we're going to multiply our top to top, bottom to bottom. So these two multiply, and these two multiply. So I have a negative 4 times a negative 1 gives me a positive 4. And on the bottom, I keep 1 times 8 is 8. Now we're just going to reduce and math frac. So it's going to become 1 over 2. Okay? So that's straight up dividing. So now we're going to read the rules. So the rules tell us for division on the bottom of your page 14. We need to factor everything first. So that's our first step. Here's the bottom of your page, says basic steps. So F for factor first, always, always. Then we need to flip the right-hand side. Okay? After we flip the right-hand side, then we state all NPVs. Last step is to simplify by canceling out common factors. That's your simplifying stage. So we're going to factor, we're going to flip the guy on the right and change it to a multiply, then do our non-permissibles, then do simplify, crossing out the common factors. Okay? So let's take each of these slowly together. So our first example is 5n, pardon me. Okay, so first step, 5n to the 4 over -2. The left-hand side stays the same. The right-hand side now is going to flip. I'm going to have 6 on top and 5n squared on the bottom. So, at this point, we can now multiply this 2 into that bracket on the bottom. Okay? So this is actually going to be 5 squared n squared, and that gets rid of that 2 there. Okay? So 5 squared n squared. Now, 5 squared is 25. Okay? So on the bottom here, it's actually 25 n squared. So, I'm just going to erase that and put that for you. So, we've got 6 over 25n squared. Okay? So, it said we had 2 brackets. That's what that 2 means up there. It means we had 2 of those brackets. Well, that means I have 2 5s and 2 n's. So you multiply your 5s, you're going to get 25, multiply the n to get n squared. So now we look diagonally. Oh, what did I miss? Non-permissibles. So, when we do non-permissibles for dividing, the rule is this. The only thing you don't look at is the top left. You cover the top left. And the reason is this. When you look at it as a dividing situation, we have the 6 on the bottom. We will eventually flip it and the 6 will be on top. So because the right-hand side was flipped, you need to use the entire right-hand side. And then you only use the bottom left. So that's why I say you cover up the top left and then you use non-permissibles from the other 3 places. So here I've only got a variable right there, and variables are the guys that do restrictions. So that guy's non-permissible is n cannot equal, I'm writing real good here. N cannot equal 0. That's our non-permissible there. Now we can cross-simplify. Okay? So non-permissibles are done. There's nothing to be factored because it's all monomials. Okay? Monomials don't factor. All we do is subtract exponents, cross-simplify. So here we go. So diagonally, 5 divides by 5 once. 25 divides by 5, 5 times. Now we're going to look at the n's. We have n2 on top and 4 on top and 2 on the bottom. How many can go away? 2. So the guys at the bottom disappear, and I have 2 left on top. Okay? Diagonally the other way, 6 and -2. What can I reduce there? 2. Good. So we're going to divide them all by 2. This will be a -1, and this becomes a 3. Now we're going to slide the top together and multiply. So I've got 1n squared, we end up with this, 1n squared times 3 all over -1 times 5. That's what we end up with. So now we're going to multiply all that. All the 3 can do is multiply to that coefficient. And on the bottom, there's no variables, we're just multiplying. So we're going to end up with 3n squared over 5, and this beautiful little negative sign down here is going to float to the top. Okay? So that would be our final answer, with no variables in the denominator anymore, which is why we always have to state our non-permissibles before we cancel. Okay? Yep.
Dishwasher.
Yep. Any questions about this first example? How to deal with a monomial? Always. Yep, in the final answer, you betcha. Okay, we're good to go with that one? All right, let's take our second example. I'm going to erase everything here. Are we good? Okay, it's going. Now we're going to take a look at that second example. So first step factor, they've already factored it for us. So this guy's already factored. All we've got to do now is flip and do non-permissibles. So the one on the right is the guy that flips. So the left-hand side stays the same, all over 3x. We're going to change the divide sign now to timesing again. And then we flip the right-hand fraction. So x minus 2, and 4 in front, x plus 1. Now we're going to do non-permissibles. So the only one we do not do non-permissibles from are the top left. Everybody else we do a non-permissible because the guy on the right was originally flipped. So bottom left, what is x not able to be on the bottom left? 0. Top right, 0 and 2. So far I've got 0, 2. What about this guy? -1. Good. So here's our non-permissibles. X cannot be these. Right there. Okay? So non-permissibles are done. We've reciprocated and flipped it. Now we need to simplify. So what can I wipe off right away? What are you noticing? Ryder? You bet. We've got an awesome bracket here. X plus 1 is gone. What else can I take away?
The x's.
The x's. So I have an x in front of this bracket, and x beside the 3. They go away. All right. Is there anything between the digits I can reduce? 2 and 4. Good. They both divide by 2. So we reduce those. Now we write down everything that's left over. So on the top left, I just have a hidden 1. Top right, I have x minus 2. So I have a hidden 1 in front of x minus 2. What do I have left on the bottom? Right, 3 and 2. I've got a 3 here and a 2 here. So I have to multiply them. So I'm going to have a 6 on the bottom. Okay? Now, they can also write the answer like this. 1 over 6 times x minus 2. They could also do that. Okay, they can pull that 6 up on here. Okay, so both are correct equations. So pretty good. Once you flip it, we're just back to the multiplying rules. Okay? All right, we're going to take a look at our third example there. Are we good to go? Yeah? All right. Let's erase all this. All right, third example. First step, it's factored. We like the ones that are factored. Now we got to flip it. We're going to have 5 x minus 3 over 2x. Divide, change 2 times, and now we're flipping. So 3x, x plus 5, 10 in front of x subtract 3. All right. Non-permissibles come from everybody except the top left. Okay, so this guy, yep, x can't be 3. What about the bottom left? 2 times what gives me 0? 0. So this guy's 0, this guy's 3. What about the top in the bracket? -5. What about the guy beside him?
0.
0. So, NPVs, x cannot be 0, 3, and -5. Now I'm just going to erase them from where I wrote them. There we go. We've got our non-permissibles listed. Now we get to start wiping stuff off. My favorite. Okay. What wipes off right away? X minus 3. I like those ones. Okay. What else gets to go? X goes. Okay, what about the digits?
Reduce 5 and 10.
5 and 10 both divide by 5. Perfect. There's nothing else to reduce. So now on top, this 1 is going to times that 3 here. We're going to get a 3 in front of x plus 5. On the bottom, these two little 2's, we have to multiply them. So we're going to get 4. on the bottom. Okay? Now they could throw that as a fraction times the bracket. So it could be written this way. Okay, both ways are correct.
But they prefer a decimal instead of 0 before.
They might. Yeah, they might. They could put 0.75 times there. Yeah. If it's an exact decimal, they could. Typically they don't. They usually deal with fractions, but. All right, we got one last big example, but this one's not factored, so we have to factor the next one. We have to do all the steps on the next one. You ready? Okay. Here's that next one. Where'd it go? My x squared, my 9. See on my other page? Where'd it go? I put them somewhere. Where'd I put them?
Yeah, those ones.
You have these next? Oh, right, because you're on the other page now, aren't you? Oh, right. Right. Yes. Okay. These guys are moving down. All right. So, we need to deal with our 7. These are the monomial ones. I want you guys to try this monomial one yourself, okay? And then we'll take it up together. It's identical to the one we did on the other page. Okay, and then I'm going to factor the next part with you. Okay, so give that a try. Okay, let's take a quick look. We're going to flip this guy right here. We have 7n cubed over 4 timesing negative 12 over 49n squared. Is everybody okay with me doing 49n squared? You know where that comes from? Good? Okay. That's what this 2 means. We have 2 of those brackets. All right. So what's our non-permissible? What can't n be?
0.
0. Good. So n cannot equal 0. Now we start cross-simplifying. So 49 divided by 7, 7 times. 7 divides by itself once. Okay? Now, if you don't like doing it this way, I'm going to show you a different way. Okay? Some people choose to just multiply the top straight across. So you would get negative 84n3. And then multiply the bottom straight across. What's 49 times 4? Let's go 6, 3, 196.
Yep.
N squared? Okay. So you could get this. So if you like to get it this way, then you don't cross simplify. All you do is you math frac that and subtract your n's. So if you find that easier, that's a different way to do it. Okay? If we cross simplify, we get to the answer quicker, a little bit sometimes. So 12 divides by 4, 3 times. The negative stays with that guy. So now we're going to get 1 times 3, or negative 3 is a negative 3. 1 times 7 is 7. And what can I do to all the n's? Subtract them, and what do you get left over? 1n on top. Okay? So this should be your final answer right here. Final answer. Okay? All right, we're going to do the next 2, and we're going to factor them together, okay? Does everybody have this one written down? You can erase it? Yep. Yep. Okay, it's going away. I'm erasing. Erase. All right. So now we're going to work on the middle one.
Yeah.
This guy on the left-hand side, we're going to factor the bottom. We're going to take a GCF of 3 out. So we're going to have x minus 2 over 3x minus 7. Now, when you're doing questions like this, if you're factoring, always look and see what the small ones give you, meaning the smaller polynomials, the smaller guys being 1 term or 2 terms. This guy's giving me an x minus 7. So typically, they're going to give you something that you can cross off and wipe out. So typically, that means it's going to be an x minus 7 or an x minus 2 over here. So we're going to now flip this guy. So we're going to flip him. So we're going to have, and I'm going to GCF the 3 out first. X squared minus 4x minus 3 is 21. 21. On the bottom, I'm going to have 3x squared minus 4. Okay, did everybody get that once you flipped it? Okay, write that down, please. That's the right-hand side flipped. And all I did was GCF a 3 out. I took 3 out of everything. Okay?
Can't you simplify the bottom right more?
We're going to factor the top and bottom right even more. The top one is going to diamond, -21 and -4. That's going to give me a -7, +3. So that's what I'm going to put in my brackets. So now I'm just going to rewrite what's on the left. X minus 2 over 3, x minus 7 times 3, x minus 7, x plus 3. All right, the top right is factored. We did the diamond and we factored it. Now we're doing difference of squares. Difference of squares mean you square root them and open 2 brackets. So I'm going to open my 2 brackets. And now I'm going to square root these guys. That's going to give me x to start both brackets. And then it's going to give me a 2 at the end. And then I separate with plus, minus. And there's a 3 in front as well I have to put down. All right. So everything is factored. Now we do non-permissibles. We do non-permissibles from everybody except the top left. Okay, top left we don't use. Everybody else gets non-permissible. So we're going to say x cannot be. Okay, bottom left, 7. Bottom right and left, right here, plus and minus 2. Okay, on the top, 7 again. What about this guy? -3. So x can't be 7 plus and minus 2 and -3. Now we can wipe things off. Okay? So what do I get to wipe off? X minus 2 goes away. X minus 7 goes away. What else? Some 3's right up and down. They go. Okay, now we're going to write down everything else that's left over. I'm going to highlight that in yellow. So we've got this left over upstairs, 3, and a bracket left downstairs. That will be our final answer. So I'm just going to write it down here. We're going to have x plus 3 over 3 times x plus 2. Okay, so that becomes our final answer. Okay, in red here, that becomes your final answer. Everything, and if you use colors, colors will help you guys. Use highlighters. Highlight the one that you don't use for non-permissible. Highlight the ones that you do, that you have left over for your final answer. It'll help. Okay? All right. We have 5 examples left. This is your practice section. This is where you guys are going to practice. Okay, we'll go over those questions tomorrow, those 5. But we're going to switch and go right to the problem solving where we have to look at the errors. So let's look at the error questions, please. We got a few mistakes we got to look at. So, the very first one up here. So, let's take a look at what they've done. They had to flip this guy. Did they flip him?
Yeah.
Did they flip the guy on the right?
Yes.
Yep. Did they turn its timesing? Yep. So far, this part's okay. So far. Now we have to see what they're crossing off. Let's check their non-permissibles. So, remember, this can't be used as non-permissible. Everything else is. So bottom left, what is A and B not able to be? 5 times what is 0? 0. So A and B on the bottom left can't be 0. What about bottom right? 0 again. The top? 0 again. So this one's got an easy non-permissible. A and B can't be 0. They've got the non-permissibles right. Okay? Now we have to see how they simplify. So, they crossed off the -2 and -4. What do you think they divide them by?
2.
2. Okay, that would give this guy a -1, this guy a -2. Okay? 15 and 5, what do they divide by?
5.
5. We get a 1. This guy becomes a 3. So, let's take a look at our variables. How many A's do we have on the top?
2.
So, I've got this guy right here, and I've got this guy right here. So, I have A squared on top. On the bottom, I have A3 and A1. That gives me A4. So, actually got A2 on top of A4. What's that going to give me?
A2 on the bottom.
A2 on the bottom. So, is A2 on the bottom here? No. All right. Did they get a -3 on top? No. So, they've got a few errors here. So, we need to have, it should end up being a -3 and all over -2A squared. Now, what happens to those negative signs? Right, because a negative times a negative or a negative divided by a negative is always a positive. So I'm going to wipe off the negatives. Well, let's take a look at our B's. We haven't done B's yet. We've only dealt with A's. Okay, now we're going to deal with the B's.
There's 3 B's.
So on top, I've got 2. 1 more makes 3. I have 2 B's or 3 B's on top. On the bottom, I have 1. So this is what we've got. B3 over B1. How many B's is that going to leave me?
Square. B squared.
B
on the top.
squared. But where does he go? To the top, because the bigger number's on the top. So we're going to have B squared on top. So they just got the whole answer wrong. Their whole answer is just wrong. Okay, so this is what they should have got. Okay, everything else was right. They just didn't get the answer correct. All right, let's take a look at B. It's a multiplying question, so we only do the bottom for non-permissibles. So what is the bottom, not x to be here? Bottom left, 0. On the right, -5. So this guy, x cannot be 0 and -5. Did they get it right? Oh, that's an error. Okay, maybe that's the only error. Let's check. So now, what are they allowed to take away? Okay, they can take how many x plus 5s away though? Only 1, so 1's still left over, so that's correct. All right, let's take our digits. So I have a 15 and 5. What do they divide by? 5, so I end up with a 1 and a 3. All right, 8 and 2, the digits diagonally. What do they divide by? 2, to give me a 1 and a 4. All right, let's deal with the x's. On top, I have x1. On the bottom, I have x2. What's that going to give me? X to the 1, but where should he end up? On the bottom. So it should be 12, and the x should be on the bottom of this guy. So it should be 12 over x times x plus 5. And they also missed the non-permissible. Okay, they only got 1 of them, and there's 2 of them. Okay, so that's what happened with that question. Any confusion with that one? Yep.
What about the x plus 5 squared?
Okay, so 1, because that means they've got 2 x plus 5s there, right? So then one of them came off here with that guy, there's still 1 left over. Okay? Any other questions about this one? No? Okay, let's look at that gigantic one. The Gigantor. All right.
Gosh.
This guy's crazy. I'll tell you first of all,
We're never going to
they
get
have
this?
factored it correctly.
Okay.
Okay, I'll tell you first of all, it is factored correctly. Now we have to check and see if they've reduced everything and if they've got all the non-permissibles. Now, one thing we have to remember, if we're doing a non-permissible, that means it's got to have, if there's a number in front of the variable, it's going to be a fraction answer. These guys have numbers in front of variables. We got a 3 there, we got a 5 there, another 5, a 3, a 3, 5s, 3s, 4s, 6s. If there's numbers in front of variables, you're going to have different non-permissibles. Okay? All right, so let's find the non-permissibles to begin with. Who was flipped? Which one was flipped? Who had to be flipped? This guy is flipped. Good. So that means our non-permissibles come from these two bottoms and this guy's entire thing. So let's do our non-permissibles. So if I'm doing, it's always for the first letter, because that's where X would be. So I'm going to take my first one right here, and that's going to be equal to 0. So you would go 3C minus 4D equals 0. And we're solving for the letter C, because that's where our X would be. So now we're going to take the 4D over. So 3C equals positive 4D. Now we divide out the 3. So 4D over 3. Do we have a 4D over 3? Yeah, we do. But they're also saying we have a negative one. We'll have to check and see. So is there another bracket here that looks identical to that I have highlighted in yellow that's got a positive in it?
Yes.
Yes. So we've got this guy's non-permissible, and we've got this guy's non-permissible. So this guy's correct with the plus and minus. Okay? Now let's look at the other ones with the 5s and 6s. They all have negative signs in the middle. So if they all have negative signs in the middle, their answer will be a positive. So it's going to be 5C subtract 6D equals 0, and now solve for C. 6D goes over. Okay. Now we divide out the 5. So we get 6D over 5. Do they have the right one? Yes, they do. So they got the non-permissibles correct. Now we have to see if they've wiped out the correct and reduced. Okay? So now we're looking to see if they reduced it correctly. Okay? All right. A negative? Yeah.
I just was wondering, above we did the solve for A and B for non-permissibles, why don't we do it for C and D?
Okay, it's because we've got a double variable and we're dealing with only the guy at the front. We would never deal with the guy at the end for a non-permissible. He'll be considered a digit similar to your constant. Okay? It would end up being your answer is an expression on purpose. So you won't get a digit answer for a non-permissible, you get expressions. Okay? That's how they end up. All right, let's see if they crossed everything out. I'm going to highlight them in green. So I want to cross this guy out. I need a negative. Where's the negative? Right there. Okay, those guys are correct. Now, this negative 5CD, where's the other guy that's negative? Right there. You can cross them out. This guy, positive, you can cross him out. All right. Do they have everything else correct? What's left over? What's that? Right. We have the 5 minus 16. So this guy stays on the bottom, and we have 2 of those guys on top. Did they get that right? Yes. Okay. So here's here. Big question. Oh, there it is. I told you something silly. I told you the factory was right.
It's not.
This is a difference of squares. If it's a difference of squares, take a look. Square root of that, square root of that. When you make a difference of squares, you have to have a positive bracket and a negative bracket.
Oh,
Here
it's
they
two
gave us
negative.
2 negatives. Is that what they should have done?
No.
No. They should have had a positive and a negative. So this guy down here is actually positive. So then what does that make us do? We can actually cross out. We can cross off one more. So our answer's wrong. So we can cross, that guy was positive, which he should be. These 2 can cross off, and that would be my answer. Okay? So, I apologize for the factoring error. So that's something we do have to look at, guys. If you're factoring these and it's a difference of squares, they have to be opposite sides of the brackets. Okay? This concludes dividing rational expressions.